I'm Taisuke Eto. Good morning and good afternoon and good evening for everyone. I'm from Keio University in Japan. So, yeah, thank you for having me and organizing this great symposium. And I'm glad to participate in this symposium from Tübingen, Germany. Today I will talk about age-related optical changes in the crystalline lens in the eye, and their impact on visual and circadian function. So, okay, I think that there are many professionals in this field, but I would like to explain in the background. The light which enter from the eye not only provides the vision, but also other physiological effects for human via the different pathway from the visual pathway. For example, the melatonin suppression and circadian phase shift and pupillary light reflex. So these effects are called the non-visual effects of light. In the non-visual effects of light, the intrinsically photosensitive retinal ganglion cell expressing the photopigment, the melanopsin, play an essential role. The melanopsin has high sensitivity to blue light region of the light. So the non-visual effects of light is strongly induced by blue light. But with aging, the ocular characteristic alter, especially pupil size and crystalline lens. So the quantity and quality of light reaching the retina also changes. Specifically, the pupil size becomes smaller with age, and the transmittance of crystalline lens decrease. Especially in the blue light region of the light. As a result, the retinal spectral illuminant decreases with aging. There are large differences between the 10 years old and 95 years old. So this attenuation of retinal illuminance may affect visual and non-visual effects of light. So the several studies show that the melatonin suppression is reduced in older adults, especially to the blue light. This study shows that the melatonin suppression is enhanced to blue-enriched white light in the young group compared with the other color temperature white light source. But in the older adults, the enhancement has not been found. So this is thought to be caused by a reduction in the amount of blue light reaching the retina. On the other hand, the children show the opposite pattern to older adults. They have stronger melatonin suppression compared to adults. The melatonin suppression in children is higher than that in adults. The black field circle and the solid line mean under the melatonin concentration under the dim light condition, and the white circle mean under the bright light conditions, and adult and children. As you can see, the melatonin suppression in children is higher than the adults. And in other study on children's melatonin suppression, the enhancement of melatonin suppression by blue-enriched light has been found only children group, but not middle-aged adults. So these results support the hypothesis that the high sensitivity in children may be caused by high lens transmittance in blue light region. So, however, it is challenging to verify the hypothesis because the pupil size can be measured relatively easily, but measuring the spectral lens transmittance in people has not well established. So this has been a big limitation in past researches. So we developed a system for measuring the spectral length transmittance in vivo that we called the system a plug-in image-based system. This method analyzes the reflection from the posterior surface of the lens to measure the lens optical density and estimate the transmittance. So the reflection images from the posterior surface of the lens transmittance called the post-plug-in images. The post-plug-in image include the information of in the lens, so that we can calculate by calculating the post-plug-in image, we can obtain the optical density in the lens. So it is the non-invasive and rapid measurement. Here are the actual measurement result of the measured optical density and estimated the full spectral length transmittance. So as you can see, in the short wavelength light region and decrease in the transmittance in the short wavelengths and age-related decrease have been observed. Using this system, we evaluate the contribution of age-related changes in pupil size and length transmittance to melatonin suppression. So the 14 school-age children and 14 middle-aged adults were participating in this study. We compared the melatonin suppression between school-age children and middle-aged adults. The experimental protocol was like this. So in the first experiment day, the participants spent time under the dim light condition like this. And on the other hand, in second experiment a day, the participants were exposed to bright light for 90 minutes to observe the melatonin suppression. We also measured pupil size under the dim light condition and during the bright light exposure. And also we measured length transmittance by plug-in image-based system. This is the melatonin suppression results. This is also the black field circle and solid line mean the melatonin concentration under the dim light condition, and the white circle mean under the bright light conditions. So as you can see, the enhanced melatonin suppression in children has been observed also in this study. This is consistent with earlier reports. So our results showed also reproducibility of the enhanced melatonin suppression in children. And these results show the length transmittance and pupil size. The red line shows average value in children in length transmittance, and blue line means the average value in adults. The length transmittance in children was higher than that in adults, especially the blue light region, and pupil size in children was larger than that in adults, regardless light conditions. These results also support the previous studies. And in addition, we calculate the pupil-weighted retinal illuminancy spectrum based on the actual spectral length transmittance and pupil size. In addition, the non-visual photoreception, which is index of amount of melanopsin reception, was computed from the retinal illuminances and melanopsin action spectrum. The non-visual photoreception was 1.5 times larger in children than that in adults. So this indicates that children have 1.5 times more stimulation of melanopsin in calculations. These findings suggest that this is the result for the comparing the melatonin suppression and melanopsin non-visual photoreception. So the children's non-visual photoreception was about 1.5 times greater than that of adults, and this ratio of non-visual photoreception was almost equal to that of melatonin suppression. But there was no significant correlation between the melatonin suppression and non-visual photoreception. So these findings suggest that lens transmitters and the pupil size may contribute to the age-related differences in melatonin suppression, at least between middle-aged adults and children. But the pupil size and lens transmitters may not explain for individual differences in this study. So in addition to circadian effects, lens transmitters may also affect visual function. So we examine contrast sensitivity under different lighting conditions in children and middle-aged adults and older adults. So the experimental protocol is like this, and this is the lighting condition. We had 6 combination light conditions. The contrast sensitivity were measured by Mars-rated contrast sensitivity like this. So this is the contrast sensitivity result. The contrast sensitivity was lowest in older adults. And there was a significant effect of illuminance, but not color temperature. So there is a next panel results show under the 3000 Kelvin color temperature condition, and the right panel mean the 6000 Kelvin. So when the contrast sensitivity increased by increasing the light illuminances. And this is the lens transmittance and the pupil size result. The children's lens transmittance was higher than middle-aged and older adults, supported to the previous studies. The pupil size were decreased by increasing illuminance levels and are largest in children in any conditions. This is the main findings in this study. The multiple regulation analysis show a significant relationship between lens transmittance and contrast sensitivity, not pupil size or age. So this means that the age-related changes in lens transmitters also affect on the non-visual function, not only non-visual functions. So in the conclusion, pupil size and lens transmitters are attenuated with aging. But the lens transmitters, it's difficult to measure the lens transmitters in vivo, so we developed a system for measuring the spectral lens transmitters in vivo. Our findings suggest that the age-related difference in pupil size and lens transmitters may affect on differences in melatonin suppression between children, at least children age and middle-aged adults. In addition, the circadian function, lens transmitters may affect on not only melatonin suppression but also visual function, such as the contrast sensitivity. These are my collaborators. Thank you for the collaborator for our collaborator, and thank you for listening for the audience. Thank you for attention.